Hello and welcome everyone. In this course, we are going to learn everything step by step about low voltage electrical panels from the fundamentals to advanced design, calculation, documentation, and testing. Please note, this is just a course overview, not the full course content. I'll give you a quick summary of these main topics, but we will cover each of them in details with practical examples through the lectures. The course will know understanding the fundamentals of electrical power distribution system, explore external distribution bulk equipment, difference between type-tested panels and local assembled panels. The course will know the project steps and rules sharing, learn the manufacturing process of electrical panels in factories, CNC cutting and punching of sheet metal and nails. The course will know different devices and how to use them. We'll know the different types of enclosure and the difference between them and how to design a panel contain different types of devices. In addition, the course will include about 100 DWG AutoCAD design files for different types of panel, starting from main distribution panels to final distribution panels, covering all the various panels types in between. This ready-to-use drawing will give you practical exposure and real reference to apply in your own project. Now, let's go through the complete journey of electrical power distribution in simple and structured way. We start from the power plant where electricity is generated at 11 or 15 kilovolts, then goes to a step up substation, raising the voltage up 500 kilovolts for long transmission line. Through the transmission network, power is delivered across region. Before entering the city, a step down substation reduces it again to 33 kilovolt or 11 kilovolt. At the medium voltage level, electricity enters a distributor's panel, a large medium voltage switchgear with many cells, each feeding a line. From here, there are two ways. The feeder goes directly to a kiosk substation that has its own RMU transformer and low voltage panel, or the feeder passes first through an external RMU, which connected multiple feeders in a loop and supplies several kiosks, or go directly to transformer for an industrial project. Also, we can connect a generator and using an ATS, automatic transfer switch. The load can switch between grid supply and backup power. At the low voltage stage, the transformer output enters the main distribution panel or MDP. From there, power is distributed to sub-main panels, smaller distribution panel, and finally to end user. We can also feed motor control center for motor loads or power factor correction panels to improve efficiency. For outdoor supply, power can be distributed through pillars of array directly to homes, shops, and street light. This is a complete electrical distribution infrastructure from the power plant all the way to the final user. After that, we will speak about difference between manufacturing factories and assembly factories. Manufacturing factories like Siemens, Schneider, ABB, and else type tested panel need some certificate and more testing and commission for many labs in over the world, like Kima, Dekra, and else. These examples for ABB Enclosure range is Minicenter, Primo, and submain distribution board like Unikit, SR Basic, and MDB like Pro A. After that, we will speak about panels enclosure materials like steel and copper, processing of electrical panels in the factories from CNC, punching and welding, and electrical and electrostatic powder painting. After the electrostatic painting, assembly the panels part, then processed with the copper and control process, and finally perform the panel testing, and packaging. We will talk about the classification of the panel according to the installation methods like wall surface, wall mounted, and floor stand. After that, modular enclosure and console enclosure. This is examples for enclosure in EBB type tested panels. And we talk about IP protection and IK impact rating and main component of electrical panel like the rail, duct, plug terminal, cable terminal, plugs, busbar support or insulators, gland, labels, and this is a content about responsibility sharing, internal project cycle life in factories, device like circuit breaker, then rail components, manual starter, contactors, overload, relay, timer, three-phase mounting relay, other devices, enclosures, and design panels. And we will talk about the project life cycle in the factory, starting from the owner or consultant up to the suppliers. Tendering, design and approval, material tendering, design and approvals, materials planning, production planning, manufacturing, quality, testing, and backing delivery. Technical responsibilities, tender, engineering, production, quality, approval stage, from the quotation, technical offer, commercial offer, finally, BOM, shop drawing, software tools, e-plan, CAD, e-design for ABB, Smart Excel, and ABB online tools. This is a component enclosure, circuit breakers. We will talk about function, principles, construction, wiring, size, and description. The design stage, how to design the panel, select the appropriate breakers, and determine the cover length and panel size. This is an AutoCAD file that contains more than 100 drawings, which you can practice on to produce a design that is accurate 100%.